Hi, Assalamualaikum. My name is Fahad bin Faris Azmi and my matrix number is 01DEE25F1137.
Assalamualaikum. My name is Muhammad Danish Kamil Hussein. My matrix number is 01DEE25F1114.
Hello and good morning. My name is Hassan Buhari bin Zanin Cham. My matrix number is 01DEE25F1154.
My name is Muhammad Azim bin Muhammad Razman and my matrix number is 01DE25F1144.
So in today's video, we're going to talk about a function differentiation in a real context life. First, what is the differentiation? Differentiation is a branch of calculus that studies how a quantity changes with respect to another quantity. So, differentiation is widely used in engineering to solve optimization problem. One common application is to determine the maximum or the minimum value of a function. In civil engineering and landscape planning, differentiation can help engineers design space efficiently. For example, it can be used to find the dimension of a rectangular garden that produces the maximum area when the total fencing length is fixed.
So right now with me, I will share about the example. First, the problem scenario. A civil engineer want to design a rectangular garden using 100 meter of fencing. The goal is to find the dimension of the rectangle that gives the maximum area. So today I will explain how to find the maximum area of a rectangular garden using 100 meter of fencing. First, we need to define the variables. Let the length be L and the width be W. Because the garden is rectangular, the perimeter formula is 2L plus 2W equal 100. Next, we simplify the equation by dividing both sides by 2. L plus W equal 50. Then we express W in terms of L. W equal 50 minus L. Now we form the area function. The formula for the area of a rectangle is A equal L multi W. Substitute W equal 50 minus L into the equation. A equal L 50 minus L power of 2. Next, we differentiate the area function to find the maximum value. dA slash dL equal 50 minus 2L to find the maximum area. We set the derivative equal to 0. 50 minus 2L equals 0. Solving the equation, 2L equal 50, L equal 25. Now we find the y using W equal 50 minus L. W equal 50 minus 25. Now we find the y using W equal 50 minus L. W equal 50 minus 25. W equal 25. Finally, we calculate the maximum area. A equal 25 multi 25. A equal 625 square meters. So the conclusion is the maximum area occurs when the garden is a square with dimension 25 meter by 25 meters and the maximum area is 625 square meters. For scenario 2, a civil engineer want to build a rectangular garden along a river. Since the river forms one side of the garden, that side does not need fencing. Only 3 sides need fencing and the total fencing available is 120 meters. First, we define the variables. Let L be the length along the river and W be the width perpendicular of the river. Because only 3 sides need fencing, the fencing equation is L plus 2W equal 120. Next, we express L in terms of W. L equal 120 minus 2W. Now we form the area function. The area of a rectangle is A equal L multi W. Substitute L equal 120 minus 2W. A equal in bracket 120 minus 2W multi W. After expanding, we get A equal 120W minus 2W power of 2. Then, so next we differentiate the area function to find the maximum area. dA slash dW equal 120 minus 4W. To find the maximum value, we set the derivative equation to 0. So 120 equal 4W. 120 minus 4W equals 0. Solving the equation, W is 30. Now we find the length. L equal 120 minus 2 in bracket 30. So L we get 60. Finally, we calculate the maximum area. So A equal L multi W. L is 60 and the W is 30. So A equal 60 multi 30. So we get A equal 1,800 square meters. So the conclusion is the maximum garden area occur when the length is 60 meters and the width is 30 meters, giving a maximum area of 1,800 square meters. So just that for me.
But the first objective is to understand the concept of differentiation and how it can be applied to solve optimization problems, and to determine the maximum area of a rectangular garden using a fixed layer of fencing. Also, to identify the relationship between the perimeter and the area of rectangle. Next, to apply mathematical method to solve real-life civil engineering problems. And also to determine the optimal dimension, length and width that produce the maximum garden area. And lastly, to demonstrate how calculus help engineer design land areas efficiently and effectively.
In conclusion, differentiation is a powerful tool that helps engineers solve optimization problems in practical situations. Through the rectangular garden example, we can see how differentiation helps determine the maximum area when certain constraints are given. The concept is widely used in civil engineering to design parks, land areas, and other structures more efficiently while minimizing resource usage.